Welcome everyone, my name is Sagar and in this video we will be learning about stack and queue data structure. So after learning about array list and linked list, so we will be today learning about two new data structures and these are also very important and particularly talking about stack. So it is one of the most important and easy data structure and you are gonna solve some hard problems or many interesting problem with this stack data structure. So first we are going to learn about stack and then queue, and we are also going to learn about internal working of these data structure, and we are also going to create our own stack and queue. So first let's start with stack. So what is stack? So it is a class in Java. As you can see, it is from this java.util package and it also supports generics. So let me just check here. So control and left click on it and you can see it extends vector. So vector is another class in Java that is very similar to array list, but it is not that much important. So that's why we will not learn about that. It is almost similar to our array list, but it is synchronized and all the methods are also same. So today we will learn about this stack. So here it is a class, but you can see we can create a stack object using this deck. So we can just use this deck to create our stack, or we can directly use this stack. So stack of, suppose type integer stack. So now let me just show you how actually this stack data structure works. So suppose there is some empty box right here, and this will be our stack data structure. So when we have to put something inside of this, so this will be a push operation. So push. So when you have to add something inside of your stack, so this will be used with push operation. Okay. So when we push something inside of our stack, so suppose there is one item, something like this, that we have to push, and it will be inserted at the top. So this is our first item, and when we have to insert our second item, so we will insert at the top of it. So this will be our second item. So that means after this there will be third, there will be fourth, and there can be as many items as we want. So this will be our push operation. But suppose when we have to remove any element from our stack, so what we have to do, so we will use our pop operation, or when we have to see whether which is the top element of our stack, so we can just do that using our peek. So peek. So let me just show you these method. So stack dot first of all push. So you can see now we have to push an integer item here, suppose one. So suppose I have to add here three elements. So 2 and 3. So now there are three items inside of our stack, and when we have to peek, so when we are peeking, so that means we are checking the top element inside of our stack, and here you can see it is 3 here. So let me just try to print stack dot peek, and you can see it doesn't take any parameter and we can just print it out. So it will just return us 3. That is the top element of our stack, and when we have to remove the top element of our stack, then we can just use our pop operation. So pop. So when we use this pop command, so pop method stack dot pop, and you can see it also doesn't take any parameter, and it will return us the element that is popped. As you can see, it returns the e element. Okay. And let me just try to print this e, and again try to print this stack dot pop. So first of all we are checking which is the top element. Let me also write here some string values. So first of all we will just peek and we will return here 3. So we will not remove this 3 from our stack, and we are just picking here. Okay. So when we peek we will get 3, and after that we are removing. That means we are using this pop operation. So after peek, we are using this pop operation, and pop means that we are removing the last element. So as you can also see here, the last element that we added will be removed first. So that means stack follow a particular order, and that is called as LIFO order. So LIFO means last in, first out. So the last element that entered here, that means the last in will be first out. So last in, first out. Okay. And I hope you got this order, LIFO order. Okay. And when we are using this pop operation, so this element will be out, that was last in, so it will be first out. And so here we will get 3. So first of all when we are picking we will get 3, and first we will remove this 3, and after using pop operation one time we will get this 2, and we are also going to remove this 2. Okay. And after that, suppose I am also doing this thing again. Suppose I am again picking the last element. So this time we will get 1 because we removed 3 and we also removed 2, and at last we will get this one. Okay. And now let me just run. So as you can see, first of all, peak top element is 3 and we removed the last element 3, 2 and the last element remaining will be 1. So that's how our stack works. But let me just show you more methods here. So we just learned about 3 methods here. So first of all, stack dot as you can see pop, that means we will remove the element and we are also gonna return it. And after that we have peak, that means we are not gonna remove but we are just gonna check which is the last element. And after that we also have this push method that will add the method inside of our stack. And after that we have this empty method that will tell us, that will return us a boolean value, either our stack is empty or not. And after removing this last one value, our stack will be empty also. And this is a search method. And I think that is from our parent class. Let me just check. Okay, it is not from our parent class method, but it is implemented here. So we can search for any element inside of our stack. And let me check more methods. So we have this add all. That means we can also add another collection here. And so there are these similar methods that came from our list interface. Okay, so there are no as such different methods from our array list or linked list, but only these 3 methods that we can also implement inside of our own stack. So we have to implement this push, this peek and this pop, and we can also implement our isEmpty method, or we can say empty. So let us just implement our own stack class. So let me just remove this thing. So let's just create our stack. And from our previous lecture, we need this node thing. If we have to implement our stack using a node class, or we can also implement it as our array list. But if you want to work internally with a node class, or you have to use the concept of a node, suppose this will be a node here, and this will have 2 references. If you don't know about node or linked list, then go watch out our previous video first. So suppose this is a node and here is our data. So suppose this is data and this is the pointer to our next, not a pointer actually, but it is just the reference to our next node. So this is our next node. So this is data and this is reference to our next node. So we can either work like this, or you can just use here an array list internally, but I will just use this node concept here. So let me just create it outside of this, or let me just create a package here that will be collection framework. So my collection, and I will just create this class here, and also I will create this my linked list class inside of that my collection package. So I will just paste it and remove this static. You can just press on Control Alt and L. You can just refactor your code like this. Okay, so this is our my linked list class and this is our node class. So let me just make it public class. So now we can just use this node class inside of our, okay, this should be imported. So now we can access my linked list also here. So as you can see, so we are going to create our own MyStack class here. So in my collection Java class MyStack. So inside of this class, first of all, what we are going to do, we are going to implement our stack using a node class. Okay, so we are going to create node. Let me just show you how we are going to implement this thing. So we cannot do it like this. If we are doing this thing, the flow is something like this, then we cannot access this node, because there is nowhere that we can get the reference to this. We have to make this node as our head. So let me just show you how we are going to implement this. So first of all, there will be a bucket and we have to just assume it. We don't have to literally create any bucket. Okay. So first of all, we have to create a new node and that will be added to our stack. So using pop operation, so using push operation. So push operation, we are going to create a new node and that will be our head. So this is our head node. Okay. It will have some data here and it will have the reference to our next value, and the next value will be initially null. Okay. And this will be our head, and for our stack we only need the reference to our head node, because every time either we have to remove our head or we have to add any element, and that will be also considered as our head. So let me just remove this from here, and you can just see your stack from the top. So suppose there is some I here, like this, and you are seeing your stack from the top. So this will be your head node. Okay, so the node that is at the top of our stack will be considered as our head. Okay, and this will be our head, and initially the next value of our head is null, and there is also some data. So when we are using push operation, so there will be a new node that will be added here, and there will be a new node here. So this is a new node, and what we have to do, we have to make this node as our head. Okay, so before making this node as our head, so first of all we have to store this previous node. So what we have to do, so this new node dot next value will be this node. Okay, and the next value of this node will be null, obviously, because this is our very first node and it will have no next value. So that's how we have this head, and this is our second value, and this is how we are going to add new elements inside of our stack. I hope you are getting this thing, and if not, let me just elaborate it again. So every time the top element will be considered as our head. Okay, so we have to first add a new node here using our push operation. So this will be a new node, and the next value of new node will be null, and there is also some data here. So this will be considered as our initial head, and when we are adding any new element here, so a new element will be this, and the head will be considered as this node now, and the next value of this head will be this previous node. Okay, and after that you can just add one more node here. So a new node, a data, and this will be our new head, and every time we have to change our new head. Every time when we are adding a new node, so this will be considered as our new head because this is a stack data structure. Okay, so this is our new head, and the next value of this node will be this. So that's how we are going to use our concept of node here, and we are going to implement the stack data structure. Okay, so that's how you are going to implement stack. So this will be our, every time we have to change our head, and the next value will be the previous head. So let me just create here a node of type t. So head, and this type will be from here. So this is a stack of type t, and first of all we have our push operation here. So push means, okay, it will return us either a boolean value if the value is added in our stack, or we can just make it a void function, void push, and it will take a t item that will be a value. Okay, and we are going to push any item at the top of our stack, and after that the methods, the another method that we have inside of stack is pop operation. So when we are removing, so we are going to remove this from our head, and now this element will be considered as our head. Okay, so we have another method as public. This will return as a type of t because we can just return as a data, or you can just consider it as a void value, and this will be a pop operation. So we will remove the top element, and if our stack is empty, if there is no value inside of our stack, then we can just return as a default value, or we can just consider this as our base case, and we can just throw some exception. So we can also create a method for this, public boolean is empty, either our stack is empty or not, and we can maintain a variable, we can maintain a member size for this. So if the size is 0, return size 0. So if the size is equal to 0, then we are going to return true, that our stack is empty. Okay, and we are going to also implement our base case here. If size is 0, then we cannot return anything, that means we are going to return null this time, or you can either throw an exception for this case, because this t is going to be an object type, and that's why we can return here a null, and if this is a primitive data type, then we can never return a null value here. So after this we have this push, pop, we also need a peek operation, and that will be exact similar to this pop, so you can just implement that by your own. So first of all we are going to implement this push operation. So let us just see now how we can add a push operation inside of MyStack class. Okay, so first of all, when we have some new value using our push operation, so we will have a new value, we will create a new node. Okay, with this value. So node of type t, new node, and we will have this value here. So a new node is created, and after that what we have to do, we have to add this to our stack, and this will be considered as our head. So head will be this new node, head, equal to new node. And is that it? No, because we cannot just do this thing. We also need the reference to our previous nodes. But what we are currently doing is we have a new node and our head is supposed there. So there is some I here that we are using to watch our stack. So suppose this is our head, and any element that is at the top of our stack will be considered as our head. And if we have a new node, so suppose there are already some elements that were present inside of our stack, suppose like this, and this will be something like this. So this is our head node currently, and this is our previous head. Okay, and when we use this push operation, so we are going to create a new node. So this is our new node that will be added, and now head is pointing to this new node. So this is also new node. But as you can see, we just lost the reference to all these previous nodes. So how can we not lose the reference? So as I already told you in our previous video, that if you are changing the value of head, so first of all you have to store it somewhere. So we have to store this head somewhere, and we actually don't need to store it, because what we have to do is, this is our new node, and what we have to do, new node dot next value will be this, because this is our previous head. So as you can see, head is currently this. So this is our head node, and when we have a new node, so what we can do is, new node dot next value will be this, and after this we can just say head is this. So that's how we can just maintain the flow. So head is this, and after that the next value will be this, and after that the next is this. So that is how we can just maintain the flow. New node dot next is head, and after that we can just change the value of head. So that's how what we can do is, as you can see, head is pointing to this, so that means this will be at our top. So here this will be at our top, and head is pointing to this, and we already did this thing. This new node dot next will be our previous head. This new node dot next will be our previous head. So this is our previous head, and after doing this we are updating the head value. So head value will be now this node. Okay, and this will also have some value, and they will also have some value. And now let us just check for the base case. So the base case will be, let me just remove this. So the base case will be when our stack is empty. So when the stack is empty, so we are just gonna add our new node here. And what we are doing, so we are gonna create a new node, and new node dot next is head. So head is initially null. So what we are doing is, this is our new node dot next is equal to head. So head is currently null. So this new node dot next will be obviously null. And after that, head equal to new node. So this head will be equal to this new node. And as you can see, this is also good. So with only these three lines, we just implemented the push operation of our stack. And now let us just implement the pop operation. So after doing this thing, suppose there are some nodes that are already added inside of our stack. And also one more thing, when we are pushing any element, you have to also increase the size. So just increase the size here, size plus plus. And when we are popping, so when we are doing this pop operation, size minus minus. So suppose there are already some nodes that are present inside of our stack. So this node dot next is this, and there is also one more node, and this is our head. So head is this, and after that the next value is this, and the next value is this, and after that this is null. Okay, so you can just consider it as our stack. You can here consider a bucket, or what you can do is you can just consider this flow like our linked list. So this is our head, and like this is our head node. Okay, so this is our very first node that we added to our stack, and this is our second node, this is our third node, and third node will be considered as our head, because we have to follow here leaf order, last in first out. This is our last element that we added, and this should be our head, because we have to remove this first. Okay, so either you can consider this flow, or you can consider this stack, this box outside of our all nodes. Okay, so let me just do this pop operation. So what we have to do, so currently this node is our head, and what we have to do, we have to remove this, and our head should be the next value. So our head should be next value, and that is the only thing we have to do. Head should be the next value. That means head dot next. So let me just show you what we did. So this is our head value, and here you can see this is our head node, and this is our head dot next node, and this is our head node. And what we just did is we just we just changed the value of our head, and what we are doing here is head equal to head dot next, and that means head will now no more point to this, but head will point to head dot next. And that means the new head will be considered as this node, and this will be out of the box. So this node will be out of the box, but currently still this node is pointing to this. The next of this node is still pointing to this, but we don't have the reference to this node, so we are gonna just lose this node anyway. So that's how we just updated our value of head, and the head will point to this. But how can we return the value of this node? As you can see, this is a type of T. That means this pop operation will just return as a T object, and we have to return. That means we have to return the value of this node, and that means we have to just first store it. So T value equal to head dot value, and after doing this thing, then we can just return this value here. Okay, so let me just show you what we are doing here. So there was our node here, and the next of this is here, and this also have some value. So what we are doing here is currently our head is pointing to this, and first of all we are storing the value of our head. So we are storing this value here. So this value is stored somewhere, so this value will be here. Okay, and after that what we are doing, head equal to head dot next, and that means the head of this value will be the head will now point to this new value, and that means this will be removed from our stack, and our head is pointing to this. Okay, so there is our node that will be outside of our box. So now this will be considered as our nodes of stack, and now this is outside of our stack. Okay, so that means this is now removed, and at last we just have to return this value. So that's why we are returning here. So this is very easy that we are doing here. This is our push operation, this is our pop operation, and the peek operation will be very easy. Public T peek. What you have to do is first of all check this base case. If size is equal to null, then there will be no value to peek, and we are gonna just return null. And what we have to return is head dot val. So this is the only thing that we have to do, because we don't have to lose any node inside of our stack here, and we have to just return the top value inside of our stack, and we are just returning here head dot val. Okay, so these are all the methods of our stack class, and now let me just create my stack object. My stack of type integer, as you can see here. Or what you can do here is you can either pass here a size, and you can just write here any constraint. The maximum size should not be exceeded, so you can just customize your own stack class by yourself. So first of all, my stack dot push. So push 1, 2, 3, 4, and now let me just do the same thing. First of all, I'm gonna peek and print this thing, and after that I'm gonna, so first of all we are picking, that means we are going to return the top element, that means the element that we added at last. So this is the element that we added at very last. So the top element is 4, and we are going to remove our our last element, so last in first out order. So this will be removed, then this, and the last element remaining will be 1. So that's how we are going to implement our stack. So now you know how you can create your own stack class, and now let me just write here some uses of stack. So stack will be used, remember this thing very carefully, that stack is very important data structure, and it will be used to solve many problems. And mostly the stack is used in those kind of problems where we have to work with the data that was present in history, or we can say that was present to us previously. So using stack we can just store our data that was previously present to us, and we can just manipulate that data, and we can just get that data when we have our current data. So like for our example, we have one very famous question that is here, parenthesis matching. So we will be given a sequence of brackets, and we have to match them. we have to tell whether these braces are balanced or not. And balance means if there is any opening braces, then there should be a corresponding closing braces for that. Here in this example, this is a balanced string because so first of all, you can see this braces is open and this is the closing braces for that. And this is open, this is closed, this is open, this is closed. Okay. And let me just show you one more example. Suppose this. So I will just tell you this is a balanced string because for these curly braces we have this one. So this is our history of data. First of all, we have this thing and this is the opening braces, and that means we know that we are going to use this opening braces to find any closing braces. So we have to use here. So this problem will be solved using a stack data structure. So what we have to do whenever we are facing any opening braces, we know that we are going to use this thing in our future to find any closing braces for that. So we are going to add this thing to our stack. So let me just do this. So for this problem, let me just make a elaboration here. So when we have some opening braces, we are going to add this to our stack. Let me just do this thing on whiteboard. So when we have some opening braces, so this is the opening curly brace. So we are going to add it to our stack. So this will be added here inside of our stack, and we have another opening braces. So we are also going to add this to our stack, and again opening brace. So also add this to our stack, and we have now a closing brace. So we know that we have faced the closing braces now. So we will check now either at the top of our stack, either there was an opening brace that was corresponding to this closing brace. So this is the closing parenthesis. So there should be opening parenthesis that should be at the top of our stack, and as you can see here, this was our opening parenthesis. So that means this data was used in our future. So that's how you can just use a stack to solve this problem. So after learning about stack, now let me just tell you about queue data structure. So now from this collection framework, our list interface is done. We already did array list, linked list, and today we also learned about stack. And this vector is not that much important, and I don't think so you will be using this in your DSA journey. So our list interface is done, and after our priority queue, this queue will be also done. So now we are just remaining with this queue data structure. As you can see, this blue one are interfaces. So how can we implement this queue? So queue will be so queue is an interface, and this will be implemented as either our array list or as our linked list. And as you can see, we can implement our queue using this linked list because this linked list, this is a class, and this also implement this interface. As you can see, this class also implement this deck interface, and this is a deck interface, and that means DEQ. So this is doubly ended queue, and we can also implement our stack using this deck interface. So let me just show you. So this is a deck. As you can see here, it is also from our java.util package, and let me deck. And if you are trying to do this thing, so if you are, as you can see here, this is the interface, and if you are selecting this, so you also have to implement all the methods that comes with this deck interface. As you can see, add first, add last, offer last, and all the methods that are present here. So after this video or after our previous video, we know how we can create our own data structure. So either you can implement this deck by yourself, but if you want to use all the given classes, then what you can do is you can just create a stack using our array deck. So now you can just use all the methods of stack. So push method is also present, pop method is also present, and you can see there are more methods that are present. That is add first, or you can say add last, or you can say uh, poll poll first, or you can say poll last. So all these methods are present in this deck interface. So now that is your today's task. You have to analyze this deck interface and all the methods present in it, and you have to implement the methods that are present here. So just implement these things, and now we have to learn about our queue data structure. So we will implement this queue data structure. So queue is also interface. So queue of integer, and let me just check. So this interface also extend our collection interface, and so we can just create our queue object using our new linked list, or we can either create or either use our array deck. So you can either create your queue using a linked list or using an array deck, and now you can use the methods of queue. add method of queue or remove method of queue, and I will just show you how this queue is implemented and how this is different from our array list or linked list, how or what is the internal working of our queue. So here we are going to implement this queue using our linked list. And now let me just show you on whiteboard. So what is a queue here? I hope you are already familiar with this word. So queue is something like this. So suppose there is a shop or there is some counter and there is some line. So there will be people in this line and they will be headed to this counter. So the first people that is in the line should go to this shop first. So that means they will follow a order and that will be FIFO order. So FIFO order. So first in, first out. So the person that entered in this queue first, so there will be, suppose initially this queue is empty. So the first person that enters in this queue will be removed first, and this is considered as our FIFO order. First in, so the person that is first in will be first out. FIFO order, okay. And suppose there are multiple persons inside of this queue. Suppose there are multiple elements inside of this queue. So this is a line, or you can say queue. If you have to add any element or any person inside of a queue, so they will be added at last, okay. And if you have to remove any element, if you have to remove any person from our queue, so they will be removed from first. So this is the order that we have to follow inside of our queue. And that's it. We have to just implement this thing in our code. So just do this thing. So in our queue, first of all, let me just add some elements. Add one. So one, two, three, four. Suppose I have added four person inside of our queue, and after that what we have to do, so they will be added at like this. And if we are removing this, so first of all one will be removed, then two, then three, then four. So let me just check this remove method. Queue dot remove, and this will just return us an integer object because this is a queue of type integer. Let me just check all of these four, and let me also add one more. So if we are running this thing, so first of all one will be removed because one was the person that was added at first. And as you can see, first of all one was removed, then two, then three, then four. And after that you can see there is an exception here. So no such element exception, and that is because of this method. We are adding only four elements inside of our queue and we are removing five elements, and this remove method is the one that is causing our exception. So these are the methods that can cause our code to stop. And instead of using this add or remove method, we can just use some alternate method that are provided in this. So instead of this add method, we can just use this offer method. So this is the exact same method to our add, and the only difference is they will not throw us an exception. So let me just check now. So instead of this remove method, what we can use is, so here is our remove method, and instead of this, we can just use this poll method. Poll. Let me just copy it. So now try it again, and this time we will not face any exception. So here you can see, first of all one is removed, then two, then three, then four, and at last null, and there is no exception now. So that means there is a difference between using some methods like add, remove, and also peek. So peek is also a method that is present here, queue dot peek, okay. And they will throw an exception like add method can also throw an exception if we are defining here the fixed size of our queue, and remove method also throw an exception if our queue is empty, and p can also throw an exception. And alternate methods are, so for our add method we have our offer, so this will also add our element inside of our queue. For our remove method we have poll, and for our peek method, so for peek method let me just show. So for our peek method we have this element method. So this will just return us element that is at the front of our queue, and this will not remove it actually. So it is like our peek method, element method, okay. No exception. So you can just use these methods if you don't want to throw any exception. And if you want to throw any exception and you want to catch it using these methods, then we already learned about exception handling using our try catch block, so you can also use that here. So these are the methods from our queue interface. And now what we have to do, we have to create our own queue. So let me quickly create my queue. queue. And now this time you know the behavior of a queue, so you can just create your methods and you can also implement them. So we are also going to need our two objects there. So first of all, we have to add any element at the last. So we also need a node for this, because we have to make the reference of our last node, that this is our last node that we just added. And we also need the reference to our first node. So there will be references to our two nodes, that will be first and last inside of our queue. Okay, so node of type T, this will be first node inside of our queue, and this will be last node inside of our queue, and T. So now you know the behavior. So if we are adding any element, so we can just use here this offer method. So I am going to create here offer method, public, and this will be void offer T val. So I am going to create a, first of all, a node object, new node with this value. So I just created a node, and if I am using this offer method, so I have to add it at the last. Okay, so the last node is initially this, and if I have to add a new node, so a new node will be this. And I hope you already know from our linked list class that how we can add a new node at the end. So this node dot next will be our new node. So first of all, what we have to do, last node dot next is our new node. So this was our last node, dot next will be our new node, and now last will point to this. So this is a very basic thing that we already learned in our linked list video. So if you don't know about this, then go check that out. And after this, last will be equal to this new node. So this is the thing that we are doing here. So last was previously here. So last dot next was just this value, this new node, and now last equal to new node, or we can say last equal to last dot next. So this is for our normal case, but suppose for our base cases, if there is no element present, then the last will be equal to null. So what we have to do, if first equal to null, or we can say last equal to null, then that means there is a base case. So what we have to do is, if there is a base case, then first equal to last equal to this new node, because currently there is no node present inside of our queue. And if there is only one node, that means if the first equal to null and there is a new node, so this will be our only node inside of our queue. So there will be a new node, and first will also point to this and last will also point to this. Okay, and after this, so there will be a connection like this. Okay, and this is our offer method. After that, we also have our public T method, that will be poll. So we have to remove our element from first. So if we have to return this element, then what we have to do, so first will be first dot next. So first will point to this, and we have to return the value of this node. Okay, so this is also a very easy method. So just store a value of our first, and first equal to first dot next now. So first is initially here, so we just stored this value, and first will be now first dot next, and we just have to return this value now. So first equal to first dot next, and we have to store here the value, and after that we have to return this value. So what we are doing here is, first of all, we just stored this value in some variable value. So this is there stored as 1, and after that first equal to first dot next. So first will be here, and we just lost the reference to this node, so this will be automatically removed. Okay, and we just have to return this value that we just stored here, 1. Okay, so this is for our normal case, and for our base case, you just have to check if our node is null. If there is no value inside of our queue, then what we have to return. So there is our base case. If first equal to null, then return null. That's it. So using this, we are just not causing our exception, and we are returning our null value. And after that, we also have our peak method that you can also implement. So these are the two main methods that we have to use. So now let me just use my own linked list, my own queue class. So my queue of type integer, and this time I have to first add a method, add any element. That means using this offer 1, 2, 3, 4, and after that I can just use this whole, and I can use this as many times as I want, 1, 2, 3, 4, 5, 6. So first of all I am adding 1. So 1, 2, 3, 4 will be removed, and after that two null values will be removed, as you can see. So this is the implementation of my queue class. So after this video we will also learn about my priority queue, and also we will learn about set and hash maps. So after learning about stack and queues, so you also have to practice some questions on that, so that you can get comfortable working with them. So today in your task number 39 you have to do these three tasks. First of all, design stack and queue using arrays. So in this video we learned how we can implement our stack and queue using this concept of node. But in your task you have to not use a node, but you have to internally create an array, and for that you can also create a constructor and get the size of an array while you are creating the object of your queue or stack. So I hope you are getting this point. So just use the array internally, and after that you can also practice some questions on lead code. So lead code question number 622. So this is the question. So you have to design a circular queue. So this is a medium level question, but don't worry, you can easily implement this because we just learned how we can implement our own queue class. So there is the first node and there is the reference to our last node, and we have to use the same concept to use this thing, to implement this thing. So just read out all the methods here. So what is the functionality of these methods, and queue, dequeue, and all the methods given here. So just implement this thing out, and after that you have to do this question. So the next question is lead code 20 number. So this 20 number is valid parentheses. So the question I already discussed in this video. So you have to use a stack in this question. So just practice this thing out, and not only these, you can also practice more questions. So just go to this lead code platform and just find these questions with these tags. So here are all these tag questions with this tag, and also there is this queue. So you can just try out all the easy questions that are already given here. So just practice the questions, and you can also learn the concept with our video. So that is it for today, and if you like this video, if you learned something new, then do like this video and also subscribe to our channel, and thank you for watching.